Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be moving our existing project, the APKOVL file, over to a new instance. So it's going to be a new installation of Alpine Linux on Raspberry Pi, and we're going to be expanding our project. So before we get into it, be sure to hit that like and subscribe button, and that way you know the next time you're going to get notified the next time there's a stream. So let's get right into the project. Okay, so here's what we're going to do. So actually, I'll show you this first. So this is what we have. So we have the Raspberry Pi 3B Plus. We have a PoE hat from Waveshare, just arbitrarily. I just chose it mainly because of form factor. We have a Waveshare 7-inch DSi LCD screen, and we have a random SD card I happen to have lying around. So what we're going to do is we're going to take the SD card, we're going to image it, we're going to copy over our APKOVL file, also our user config file. That way we have all of our settings, everything else like that we need in order for the resolution to run. And then we're going to pretty much copy it in. I made a few modifications to this image versus the one that we did previously in our project that I used for myself, but we'll see it as we actually go through it. So it should be a lot of fun. But this is kind of a regular way that you would deploy one of your own images if you didn't have it pre-packaged. So if you're not creating packages, you're just creating like one-offs and you want to be able to duplicate it, this is kind of the process that you would do to be able to do it. Now we're going to go through it step by step, so hopefully it should be easy to follow along. So first thing that we're going to do is we're going to download the image that we're going to use. We're going to update this as well. So what I actually built it on was not the latest version, because obviously they've released new versions since that time. So we're just going to download the latest version. That way we know that we're starting off in a good place. And you'll have to excuse me, I don't have my usual monitor set up for this, so it's going to probably be a little bit clunky. But so we're going to download 3.20.2, and it's going to be the tar.gz file, since this is for Raspberry Pi. We don't need to image it. So we go ahead and download that. And here's our APKOVL file, .tar.gz. That's what we're going to be copying over. But let's go ahead and open up our what we just downloaded. We're going to extract the contents of that image to the SD card. So let me go ahead and put this in the SD card reader and pop it in the computer. Alright, and we're going to open up our downloads directory. I'll open it in a new tab here. And there we have 3.20.2. And we're just going to extract it to that SD card, which may actually need to be imaged now that I'm thinking about it. So let's go ahead and do that first. So first we need to set up a partition. So we're going to go into disk management. I am using Windows for this. Forgive me, but it can do this on Linux or Mac as well. It's not a big deal. So what I'm going to do is just create a new simple volume, which will create a single partition that uses the entire SD card. I'm going to use the default values for everything. The only difference is for file system, I'm going to choose FAT32. And in this case, I'm just going to call it clock. That is what we're building. We're building a clock. So we'll let that finish up really quick, and then we should actually have a volume that we can dump our files to. Perfect. So it says it's healthy, and the partition is formatted. So now we should actually be able to go in and choose it. And just to make it refresh, I'm just going to go to extract again. And there we have it, clock. So I'm just going to select that, hit OK. So now it's going to extract the image over to the SD card, and that will effectively install our operating system. So we'll just give that a second here to complete. Perfect. Now we can close that out. I'll close out the downloads folder as well. in here we have two files that we need. We have the user config.txt. I'll open that up for it really quick. And we see we have a couple of things: DT overlay, disabling Bluetooth, enabling serial, a few commented out things here, but pretty much the big thing that's important is the HDMI CVT, which is doing the 480, 320, 60, which is the resolution that we need in order to run this. Even though the actual physical monitor is capable of a much higher resolution, we want to make sure that we're kind of keeping it to where, since this is all text mode, that the text is readable from a distance. That's pretty much the important thing for me in this particular application. So we're going to leave this as is. If we need to modify it, we will, but that's kind of what's in it. So we'll copy that. I'm also going to open up Clock in a new tab as well, just so we can copy back and forth easily. And that goes right in the root. Woo. Yeah, I like this view better. Okay, so there it is, user cfg.txt. Next is we have the APKOVL.tar.gz. I will show you what's in here, and pretty much it's just a few files. It's going to give me a bunch of things because I need to rebuy the version of WinRAR. So we have the bin file. So this has a few things in here. So NTP Clock and NTP Clock temperature. So I have a weather station that I built at my house using Raspberry Pi as well. At some point I'll rebuild it and we'll do it together. But that kind of gets me local temperature, wind speeds, things like that. A lot of statistics about what my current environment is. And that feeds into the NTP Clock script to be able to populate some additional information as I'm looking at it. Like a rain sensor will tell me if it's raining. So things like that. We have the config. This is pretty standard stuff inside of NTP Clock. We have the configuration file. Nothing too special there. And then in user lib, Python 3.8 is what we're going to have to install, but we're hopefully going to have this install it itself, which is why I chose ARM v7 instead of AR64. That just happens to be what I originally created this on, and want to see if I can carry these packages through. So we have Astral, Colored, Cursor, DateUtil, PYTZ, and Redis. So this actually does rely on Redis for that backend communication as kind of an intermediary database to go between the temperature process and the clock process. And luckily, if it doesn't install correctly, both of them will crash out, but it should give us some good errors, so we'll do some debugging should that be needed. So let's go ahead and copy this over. We're just going to copy that into the root as well, and then we should be set with configuring our SD card. So now that that's done, I'm going to eject this. All right, and then we can move into our configuration or our physical build. So what we have is pretty much brand new items in boxes that I haven't really opened before. Nothing too special here and nothing too crazy. I am going to make a nice little case for it, but we'll pull everything out here. So we have a brand new Raspberry Pi with a bunch of PC board whiskers on there. But this is ready to go. Then we have our Waveshare LCD. And this comes with a number of cables, things like that, so we can interface with a Raspberry Pi at a distance, a Raspberry Pi, a Raspberry Pi, well, anything from the Raspberry Pi family, and then a short one, which is the one we're actually going to use. I don't know why the name of that Raspberry Pi is escaping me. I was going to call it a Pico, but it's not. Anyway, so this is the actual Waveshare LCD. And this is the back of it. So the front of it, it's got this nice bezel around it, which I really liked. And the key thing is it actually has some double stick tape, so that way I can attach it so I can cut a square hole inside of some bezel material, and then be able to adhese this to it and or bolt it to be able to make it so it's got a nicer appeal, you know, aesthetically than I otherwise would with just using the raw LCD screen. So it's very nice. It does have a plastic protector on there. I'm going to leave that on there until I actually build the however I'm going to mount this. So let's do the assembly really quick. I don't know if it has enough screws. I don't know. I'm going through this in real time as we're doing it. So we're going to see together whether this works in such a way. Just dump stuff out on the table here. And there's a few features that we're not going to be using. We're not going to be using the touchscreen on this in this particular case, just because it's not really necessary. It does have a standoff kit that it includes, so we are going to be utilizing that. And I have been in the process of kind of like rebuilding my office, well, studio space in this particular case, to try and make it a bit more ergonomic. So things are still a little bit in flux. So you may notice some different changes or whatnot. Hopefully not, but you know, if it looks that way, that's the reason. So first thing we're going to do as far as assembling this, obviously we can't mount this to this with these protective Captain Tape covers. And I'll zoom in here for you on that. So we need to just remove these, otherwise we're going to have to try and press through them, and that's going to be really annoying. So let's see if we can pull these up really quick. I'm just going to use a flathead screwdriver. It's just threads. There's nothing electronic about it. And just see if we can get at it. Sometimes you can also get it from the edge as well. These look like they're pretty close. There we go. I did get it from the edge. And we'll just put those over to the side. Let's see if we can get that luck. Oh, look at that. And we're just going to do the 4 relevant ones right now. And there we go. So that's all 4 done. Next, we're going to be mounting this on here. We do have our DSI, which is directly underneath it. So we do want to put in our cable before we do that. So we're going to pop out this little retainer clip. It does go contacts up, right? Because the black side presses just against it. And we're going to insert this side first, press it in, hopefully. There we go. Right, so now we see it's fully seated, so that way it's not going to be in a scenario where we're having to try to do it with the Pi installed. So, very important. Right, there's still these little tiny whiskers here. I don't know if you could see that, where they had a, the brake was not clean, so I'm just gonna pull those off, but they won't actually impact the ability of the board to operate. And I've never used this before, so we're just gonna, hopefully it's not a crib death, as it were, or a anything else like that. And what crib death means is that it's right new out of the box, and it already is not working, or has malfunctioned to the point where it's no longer working, going to ever work. So if that wasn't apparent by context. So I'm just going to put in these standoffs really quick. We'll get them all started before we tighten any of them down. Having the Ethernet connector there makes things easier. Just kidding, it really doesn't. And I'll try to do this up on end so that way you can see what's going on. Alright. Alright, so they're all started, so let's see if we can get them all tightened down. Now the key thing with this one right here that I'm doing is I don't want to bend any of the pins as I'm actually screwing it down. Like that. See how I just bent it? And these 4 pins here are critical for our application because we are going to be using the PoE hat in order to be able to try to power this. So we will see. I have a backup plan for that as well if I make a mistake while doing this. Alright, we're just gonna screw this in all the way and then we'll bend the pin back. And this is the critical one that's actually going to hold on our PoE adapter. All right, so let's see, did I break it? I think that worked out all right. Let me do. Just try to finesse it back into shape. I think that'll work out just fine. So we have 2 more here. Did I tighten these? No, but at least I can spin them. Without taking off all of the pins. Okay. So now everything's solid, so this is firmly attached. Next thing that we have is the WaveShare PoE hat. So it does actually seat on just like this. It does have a couple of pins here in terms of SDA, SCL, which is SPI interface. Or excuse me, I2C interface, but it is something where I'm not going to be using that in this particular case. I don't care what the power draw is. I just want it to be able to power it. So, minor issue. After we went through all the trouble to try and bolt that down there, I actually need to use a much, much shorter one. Because I just noticed these are on the top. So both of these are not going to work on this side. So I do have some alternative standoffs. Let me go ahead and grab those really quick. Hopefully. Where do I have those is the question. Oh. I probably could have checked that before. Went through all this trouble. Okay. So we need much shorter ones. Otherwise, we'd have to leave it free floating. A little bit of metal dust from where I was messing around there. So let's see what we got really quick. Got a nice smaller ones. Have one the right size. Let's see. That's always the challenge, is trying to figure out what they're going to include and versus what you're going to have. Yeah, I don't like the options I have with that. So, how about we do this? Oh, that could work. So here's what I got. So I got an old bag of nuts, pretty much. I don't need all of them. I'm just gonna dump them out. I don't know if they even fit. Let's see. Are these the right size or are these M3? These feel very M3. All right, so those aren't gonna work. What else? Oh. Those are definitely M3. These look like the same exact ones. Oh, these are M3 as well instead of M2.5. You can't see it. And then I have M3 bolts, but that's not going to help us. So Raspberry Pi is M2.5 is the actual hole size instead of M3. It's kind of a weird size, but it's always been secure enough anytime I've used it. So we'll skip that one. We have some screws here. So we may be able to just use those. So let's just put the hat on here. See where we actually get. Right, so that kind of fits there. Can we screw this all together? And the reason I like this particular PoE hat is it fits within the overall profile of the Pi itself. So the whole thing is there and it can do 2.5 amps, which is quite a bit of power. So that's not going to work. Let's try. Will this work? I think this is going to be. Yeah, it's not even going to go. So, assuming that this can hold its own weight, let's just try screwing the board down using the regular screws here. And that will be enough. That way the board's not flapping around and stressing our DSI cable. Okay, so before I put this on, even though it's right here, I'm gonna put on our DSI connection first, just because the tolerance is a little bit low to where I think it's going to be difficult to try and press it in with this on. So we're going to pop this out a little bit, take off the little tiny piece of Captain tape that's on there. They like their Captain tape. And this just curls over and in. Again, the contacts go towards the white side here. And the nice thing about the DSI connection is it automatically detects and will carry power and everything. So I just make sure that that's fully seated, right? So I can't see the contacts anymore. And then I press down the two black holders to retain it, right? So it looks like that. So now the whole thing is within the same profile of the actual Pi. That way it's very thin. You know, it's not an issue in terms of it working or anything else like that. And now we can install our PoE header. And that pretty much completes the physical assembly that we're going to be doing together today. Right? And I think that's more than fine. I don't think that's going to be falling off or anything like that. And you see how that just kind of grabs onto those pins there. They still kind of peek out, but not really usable anymore. All right, and we're not going to hook up this, which again is the I2C connection either for touchscreen or the fan, because we just don't care. It's not a touchscreen device, so at the end of the day, it's going to be fine. So let me move all of this other stuff off to the side, and I'm going to show you a fun little thing that I just did. Ready? The SD card is supposed to fit in here, and I didn't put it in yet. So I guess it's good that we left this so it can be removable. Now, there is a way that we can actually extend this, so that way the SD card is not actually underneath like this, which makes it easier to take it in and out. All right, so I'm just going to undo this top one. That exposes the bottom SD card, and then hopefully I don't slide it between the boards and lose it. And hopefully it works, because pretty much the DSI is going straight around it. Same thing with the Raspberry Pi 5. You have the same issue with the PCI Express connection, where it kind of does the same deal. All right, we press that down again. All right, we see there's no exposed contacts. Pop back on our PoE. Then we should be ready to fire it up. So in my case, I am going to be using KVM for that. So we'll just go ahead and hook this up. We're not going to hook up any power, but we will hook up. We don't need HDMI technically as well, but I do think it's going to make it a lot easier in order to be able to use it. We'll see. Let's actually just try it with the on-screen monitor and then the USB. And with any luck, it will just kind of work. So I'm going to plug in the USB, which is just for keyboard and mouse, and then plug in the Ethernet, which should have PoE attached to it. And let's see if it boots. And it may not. No, it did. Will it have live? Otherwise, we'll hook up the HDMI. And this is one of those situations where it may not be compatible with our particular file. And I don't see any activity running here. I don't know why that shows up green like that. It's red. But the activity LED is not lighting. Nor is the display. So let's go ahead and check that out. And I think I have that in 3. And I'm not going to be able to see it. So we will hook this up and reboot it really quick and see if we can get output on the screen. So let's go back over to our KVM. I'll pop this in here just so you can see what's going on. Oh, I didn't retitle this. Oh well. It's not actually an x86-64 PC. I forgot I didn't retitle it. Anyway, let's reboot this. Now we should come up with output, if nothing else, just so we can see it actually doing something. Right, so it did power up, there was a momentary activity, there's a little bit of activity going right now. Let's see. Still nothing on the screen. We may need to connect this in order to be able to get it to power. It may require the additional 5 volts, but it says that's for the fan. And generally, I haven't had to apply separate power to these before. So let's see. There is also some other adjustment. It's supposed to be software-controlled backlight, so it may not have that. So we may need to look at the actual installation instructions from Waveshare in order to be able to get this to run as well. But right now it is not running, so that's fine. And I don't see any video. Am I on the right screen? Let's see. Nope, that's not this one. So what we can do first is we can actually disconnect the DSI. So we'll disconnect power, disconnect the DSI, start it up for the first time, make sure that it's going to run using the HDMI output to be able to actually get it set up. And then we'll be able to get everything else going. Alright, so we just disconnected the DSI, so I'll plug it back in. So now it's not going to be using the onboard display at this moment. It should be coming through so we can see it working with the actual output. And let's see what we got. Do we have any? Okay, so here's what I'm going to do. I'm going to delete the user CFG because we're not getting display. We are seeing activity. Oh, and I got it. So let's pop this back in the computer. So we might have jumped the gun on adding that user CFG because I'm not sure that it's actually a compatible display mode for either this display or the HDMI output. So we'll check that really quick. So let's see what we got. So we'll go down here. User CFG.text, we'll just delete that because since we copied it otherwise, and we'll just eject it right away. There we go. All right, we'll switch back over to here. We'll pop this in here. And go ahead and boot this up. While that's booting, we're going to go ahead and check this out. Still not seeing any output, which is only slightly disconcerting. I may want to just double check my cabling here really quick. Just going to change that really quick. So it didn't come up. Let's see what we can do about this. I just want to verify and make sure my video connection isn't doing something weird, because I'm actually not seeing anything coming in from the Raspberry Pi itself. Oh. Because it's KVM2. Just went through all the trouble of retitling that. Alright, so we're going to use input 2. Alright, so it did come up. So now we can actually just get everything set up. So we've already loaded our previous configuration, but not everything is installed where we need it to be. Just for the time being, I'll get rid of the camera here just so I can type. I'm just going to log into this really quick. I did previously have this deployed in my living room, or my dining room. So hopefully it's good. Alright, and pretty much what we're going to do is just do APK add with no other commands in order to be able to install everything that it's referencing and make sure that it is actually available to run. Okay, so right now it says unable to select certain packages. Specifically ncurses, term info base. So why is that? Do we have community present? We actually have the wrong repository present. So let's go ahead and update that. So we'll do vi/etc apk repositories. And I don't have a way to zoom this, I apologize for that. But right now we're running 3.20. So we're gonna do that right here. I'm gonna leave the edge as is and leave the local repository as well on the SD card and do the same thing. And here we see it installing everything. It's going to be compatible because it is the current version of it. And that looks like it. Let's make sure. So we have the Python PY3. Looks like 3.12, which means it's probably going to break all of our specific packages. So all of those Python packages that we had pre-installed in 3.8 are no longer going to work. So we may need to reinstall those, which is fun. So let's actually check that out really quick. So it actually gave us what we would need to run in order to do this. Let's just do screen-ls. It is, oh, it's not screen. Right, we have NTP Clock and NTP Clock temperature. So I'm just going to do NTP Clock stop. And it does say that, which is fine. We're going to ignore that. Alright. And that was already stopped. So there's a little glitch inside of that code. This is older code. I've since fixed this for the demo and also for the other one. And we'll also stop clock temperature as well. And that's going to do the same exact thing. Let me see if I actually made it so it stopped at 10. I don't think it is. So we'll stop that. Okay. So, I'm not sure if you could read this. I could barely read it. I'm going to try and make the text bigger. So what I'm going to do, I'm going to change over to a different cable, which is input 3 as it were, which is bigger on the screen, and I think that's going to be a little bit easier to look at. So first let's do lbu commit-d. Alright, and let's see Python -v is 3.12. That was verbose, by the way, not anything. So we don't have any of our packages installed. I don't know that we can easily downgrade. Let's see. Let's do APK info. We see 3.12, but I'm not sure if that's the only version available, so we'll do version. Let's see. No, I don't think we can get all versions through this. Also, I don't know that they have the version built that's the 3.8, so we'll have to reinstall it, but that should be totally fine. So we'll be able to look at that. I'm probably going to connect through SSH in order to be able to do that, which may make it easier to read as well. So let's actually just do that instead. So I'm just going to do ifconfig, that way I know what it is. So 192.168.35.100. So let's switch back over to our machine, and then we'll be able to do the rest of the configuration from there, hopefully. Okay. All right, so this is it currently. Okay. So let's look at what our running when we try and run it, just so we know what's broken. Module not found, named requests. So again, that's a issue with Python. That is a Python error. So let me move this over so I can type more easily. We're going to do APK search, and we want to search for PY3 requests. And see how much of this actually has the libraries available using the existing package manager. Otherwise, we have to jump through hoops to get pip3 to actually create the actual installer. So looks like we got plenty of options here. So let's just install it. And then we'll run it again and see what else is broken. Okay, PYTZ. And I think that's the right one. It says the other one is PYTZ data. So it may require that. Let's see if it actually resolved it, otherwise we'll install that one instead. Nope, it did work. So let's search for that. It may not have it, but this allows for the colored text. It does have it, excellent. And the nice thing about this is that you don't actually have to do special exceptions to include this in your LBU commit. It will automatically include it as part of the regular commit because it's a package. So that's the reason why they like to use this over actually building it and installing it through pip. date util. So same deal. We want py3 date util. Okay, cursor, same deal. So we're just going through and we're identifying the lines. We're running it manually right now, not as a service. And pretty much what cursor does, by the way, is just mute the cursor. So that way it's not blinking. I don't see that it exists there. So that actually may be an issue. Okay, so we'll notate that and we'll come back to it. Actually, we'll have to resolve it, otherwise it's not going to work. Right, because if we just run it again, it's not going to have anything installed. So it is a Python package just because it is using the import command in order to be able to bring it into the actual script. So cursor, let's try pip. So we are going to add, so we're going to apk add py3 pip. It's going to complain at us. It's going to say that it doesn't like it, but we're going to do pip3, and let's just run it without any command really quick. Perfect. So we'll do pip3 add cursor, which we know does not exist as a package. Install, excuse me. So we know it's not available as a package. Now it's telling us that there's a thing here. All right, we're just going to read through this really quick, but it says externally managed environment because it's managed by APK. So it's going to break it. We will have to add it. So we're going to go in and we're going to say, if you believe this is a mistake, we're going to have to do break system packages as a flag. And then it should install appropriately. It may not be able to compile it because we don't have any compilation tools installed, but let's see what's required in order to be able to use it. It will tell us once again. But it says it successfully installed it. So perfect. So we are going to have to make sure to add this particular distribution in this particular this particular package to LBU because we installed it outside of root. So just something to keep in mind. We'll do that momentarily. Okay, Astral is another one. I don't believe that this exists as a thing. We will have to use pip to install it as well. Oh, it does have it. Yes. Okay, and Redis. And we're looking for the PY3 variant really quick. Not the, because Redis is obviously its own server as well. So we already have that installed, hopefully. We'll find that out. Let's see what else. Perfect. So it's giving us a large traceback here, and it's saying connection refused, probably because our Redis server is not active, but it did actually make it through initialization to be able to crash this far. So we'll stop there momentarily, and let's move on to our temperature script. just make sure we have all of the dependencies that we need for that. And it looks like it is actually running. It doesn't have any display output or anything like that, which is fine. Right, so we do see that it's running. The only time that it actually exited out was when we exited it. So, perfect. Okay, so we have all of our dependencies on there. First, let's add our LBU to there. So, let's find our package. Easy way to do that is we're going to just go into the existing LBU or APKOVL to be able to check that. Assuming it's awake. Oh, I see what happened there. Just a moment. All right, so inside of our APKOVL file, we can look, it's under user, lib, Python, and then the version. So let's verify that. So we'll do ls/user lib tab Python 3.12. Right, we see that's there. And then it goes deeper and shows us, where is it? Right here. Site packages, and then the packages that are there. Right, so we have site packages, and then specifically the one that we had to install make sure it's here, was cursor. So we're going to do LBU add and then cursor, which should include everything. So if we do LBU list, we see it all there for cursor. Oh, yeah, and you see how it has 3.8 here? We can actually get rid of all of that. So we're going to do LBU exclude /that/star. So now when we do LBU list, it still shows up. Perfect. Let's try that. Well, it doesn't want to exclude it. But if we scroll up here, we see that there's quite a few things in relation to zone info, things like that. It's not going to impact anything. We can actually delete it as well, but it doesn't really matter. So let's do LBU commit-d just to save the work that we've done so far. And now we should be able to make sure that Redis server is running appropriately. So we're going to do /etc/init.d Redis start. Okay, and it's starting the run of the Redis server. We are going to add this as a actual boot process. So we're going to do rc update add Redis default, and it's already installed there, so that's perfect. And we'll just save it again. So now that that's running, we should be able to start our temperature sensor. We're going to restart it. And what you see here is it's actually just erroring, so I need to correct that script really quick, otherwise it's not going to actually do what it's supposed to without a reboot. So let's go ahead and fix that. I need to edit the right script. So we're going to start with temperature. And it looks like it doesn't have an explicit stop command. So it's just running it in the background. So theoretically, it should also time out. So let's see really quick. Nah, I'll leave it as is. We're just going to restart in order to be able to resolve this. So I'm just going to end all of those processes or verify that they are. I want to see how long this actually goes for. Oh, it's waiting for NTP Clock to stop. Wait a second. Wait a second. Because I do have that registered as a dependency. Let's edit the correct script that is actually showing the issue. This one does have a stop process. So this one is while OpenVT is open. So it's not using screen, it's using OpenVT. That's what we used previously. It's going to keep adding it, but it doesn't have a terminator to be able to say it's already, or it's not stopping. So I want to put a timeout here. So what I'm going to do is counter equals 0. Sleep 1, and then we'll do if counter is less than 10, then counter equals counter plus 1. Then we'll do else break to break out of the while loop by. Okay, so that's all we're adding there. So it's initializing a counter. It's going to wait till the counter is at 10 or is less than, while it's less than 10, it's going to continue incrementing the counter. And of course, once it reaches 10, it's just going to break the loop and exit out. So let's go ahead and try this. Right, we're still restarting temperature, but let's see what we get. 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we do see that it did finish properly. We didn't put that it was doing anything crazy. Totally fine. So we'll do OpenVT -ls, or let's actually check. Do we have OpenVT installed? I don't know that we do, but that actually should show it on the main display. So that's fine. So I'll stop it really quick. It is already stopped. We'll do start, failed to start. OpenVT is already running. All right, and now it's started. So we don't actually have, oh, we do have display. Wait, let me switch to the right one. That looks great. Nothing there. All right, so it's not outputting anything. That's totally fine. Let's reboot it. Just to make sure that everything's running as we expect. I'm going to switch back so we can watch the boot cycle. Now, we still haven't connected the DSI connection yet, but we're planning to do that right after this. But we're still going to keep the user CFG out of it just for the time being until we can kind of get that all settled out. But it should still work. It should still display something. So same IP address, everything else like that. Let's see if it'll start up. We should see it starting Redis server. We should see it starting NTP Clock. Can't execute no such file or directory. But it does exist. So something must. Okay. I am going to try it from here just because this should show us it working. I mean, technically it should show us working on the other one as well. So I'm just going to do NTP Clock from here. And it's saying something's not found. So it's not actually the process that's not found. It's something within the process that's not found. So let's find out what that is. And this is definitely the kind of thing that you would need to do in order to be able to, you know, if there's any issues with converting over, especially if you haven't taken notes on what you actually have here, it is something you would need to be able to troubleshoot on the fly. All right, so we see a few things. Nothing of issue here. It does say it needs Python 3. And usually when it says ash not found, that's what it's referring to. So let's just make sure Python 3 is there. It says Python 3 is not installed. So we have a cache sync issue, which is also why Redis didn't install as well. So let's do APK add. So it didn't reboot successfully, right? It kept all of our changes that we put in LBU, but it didn't install any of our packages as we see right here where it's installing them all now. Now it will run successfully, but we want to make sure that this preserves. So what happened is that we don't have our APK cache defined in a proper way because it's still using the identity of the old SD card. In order to fix that, we're going to do setup APK cache, and we're just going to choose the default, which is literally what it's been trying to use. And then we're going to do APK cache sync. And we'll add some V's in there. We need to do APK update first because now we've changed that location. And now we'll do cache-vsync. And we should see it download a whole bunch of packages. These are just downloading, they're not installing, but that way they're available the next time it boots. So we'll do LBU commit-d, that way we save that change. We don't have to do this for repos or anything else like that. LBU is working as expected. Generally, that does persist past moving the files, as long as your actual home directory or your drive, the place where you're saving it, doesn't change. I don't know why APK cache is different. It just likes to be a little bit different. So let's go ahead and just try rebooting once more and just see how it comes up. Actually, we could test it first. So let's do NTP Clock. And we should get... Oh, that's beautiful. And it's because Redis didn't start. So let's restart Redis really quick. I want to see it do an output. Let's see. None type, we need to restart this. It's a lot of things here that are interconnected, which is kind of annoying. So yeah, in the future, I do want to make it so it's less of a thing. I actually stopped using Redis in a lot of cases for doing this kind of thing, and actually I'm using text files. Since Alpine Linux is running everything from RAM anyway, it doesn't really care. It's going to run it from RAM, which is the same thing that Redis is doing. So for individual values and things like that that need to be included, it's a lot easier to just read repetitively from a text file than it is to do anything else. So it says everything failed to start. Beautiful. So let's do NTP Clock. And let's see what we get. And look at that. We have a clock. We have a temperature. We have some wind headings. Everything else like that. Oh, that's a beautiful thing. And it's the accurate time. So let's exit out of that. Perfect. So that's doing what it's supposed to do. And that's OpenVT, by the way. That's pretty much taking over the terminal and then giving it back once it exits, which is nice. So that's what we want. So now if we reboot, so I'm going to do lbu commit-d, right, since we have it working. Let's go ahead and reboot. Now we can switch over to our other, oh, we're on the KVM, so we should see it actually do things. So let's see it start up. I just want to see it activate the clock on its own, and then we'll reconnect the DSI display, and then we'll get our user CFG file configured, and then we'll hopefully be done. Getting network. Good, we see a lot of configuration warnings. That mainly has to do with syslog. And there we go. So now it loaded the clock successfully. So I have it showing the IP address, I have it showing the date, I have it showing the temperature, and it is showing blue right now, but it changes to white when it's during the daytime, so it's a bit brighter. I just like it in terms of being able to be adaptive in that way. And in that blank space in the middle, when it's raining, it actually says rain, just so it's easy to identify when you need to bring a jacket or dress appropriately. So, perfect. So now that we've gotten that, let's go ahead and get our DSI connected. So since it worked, and I'll go ahead, we'll unplug this really quick. Okay, we'll get our DSI connected, so I still have this pulled up. Right, we'll just press that in. Lock it down. I'm going to unplug the HDMI. And then we'll go ahead and plug this in. All right, and I'll turn it right side up so we can watch it together. Hopefully, it turns on. So there are lights, it's booting, says it's doing things. We may need to enable something in order to be able to get it to boot, but we'll be able to do that using the actual, see if I can keep it from glaring here. We'll be able to do that using SSH. So I'll switch back over here. I'm gonna switch over to our KVM. I'll put this up in the upper right hand corner just so we can see it. We'll go ahead and we'll restart this just so we can see it again. We do see that it is fully up. And then I'm going to put in a password really quick. Okay, and what we're gonna do is we're just gonna look at this WaveShare LCD screen really quick. So let's see if we can find it. And this looks like it. Right, looks very familiar. So let's try and find the instructions on how to activate it. I'll turn this off for a second, just so we can see, but we have the MIPI DSI, low power, blah, blah, blah. Supports everything. Oh, do I have it plugged in on the wrong connection? What am I plugged in on? Am I plugged in on the camera? No. Oh, that's a Pi 5. Oh, wow. Wow. There we go. 4B, 3B plus. I mean, you know, we're gonna pretend that we're gonna pretend you didn't see that. Okay, so we need to get this installed. So let's go. We have brightness via software, everything else like that. We want to see if we can get this going. So let's go to the wiki. Hardware connection, blah, blah, blah. This one has it, but it does require some stuff in terms of using DT overlays, things like that. This looks like it's specific to Pi 5. Nice thing is we can actually use the same thing. So let's see what we could do. So what I'm going to do is I'm going to put the SD card into read-write mode. We can actually move this over. That didn't make things easy. There we go. Put this here. All right, so I'm going to do mount -O remount comma RW /media / this is counterproductive. Let's swap these two. There we go. Media / MMC BLK0P1. That should remount. And now we should do VI / media MMC BLK0P1 user CFG.txt. We're not going to do the config.txt because that references the user CFG.txt in Alpine Linux. Okay, so we're just going to do this from scratch. So let's do DT overlay equals VC4 or VC4 -KMS -V3D. And let's see. And it says we need to add the DT overlay. Let's see if it has some specifics for Raspberry Pi 3B plus. Okay. Well, let's try it. It either works or doesn't. And let's try DT overlay. Let's try it. Let's see. So it is doing things. Lights are on. I don't see anything happening here. So none too happy. So let's see if we can do DSI display specific to Alpine Linux. So there is one here in Alpine Linux packages. So Linux LTS, I'm just curious. So let's actually restart this connection here really quick. Let's just see if we need to add firmware. And what is it? So Linux LTS, let's see if this works. I see all kinds of errors. That's excellent. So Linux LTS is pretty much installing all the drivers that are available. A lot of them do not exist on the system because this is Raspberry Pi. So it shouldn't matter the fact that they're not able to be installed here. So this is not actually concerning. Look how happy it was. It's not happy. So let's actually see if we can get this to go now. So we'll do lbu commit-d, either works or doesn't, and we'll reboot again. Signs of life, maybe? See activity. Let's see. Not yet. It may take it 6.5 hours because we just tried to install all of that. Okay, it is refused, so it is booting up. We're just giving a second here. So let's undo what we just did. So we'll do APKOVL Linux LTS, which is long-term support. So it's legacy hardware, things like that. This is excellent. Are we gonna have to wait for 113 of these? Actually, I'm curious if this is trying to bork the system. So, yeah. Let's make sure that all the stuff we actually need is there. Alright, so let's try this. APKOVL Linux firmware -star. Because I think it's the firmwares that really killed it. Right, and we see Linux LTS. Okay. Let's try it. Doesn't seem like it's doing a whole lot. Like the activity light's not really moving at all. IF up down is not a good sign. I mean, we're connected to it over the network, but that's kind of annoying. While this is happening, let's see if we can search for an answer, because this is going to do whatever it's going to do. So let's get rid of that. Make this full screen. Okay. So let's see if we can find DSI. I'm going to put DSI in quotes just to make sure that it is including that. Now, granted, it did say that we had to do the other thing with the DSI 0 for the other thing. It does look like this is chugging along. So it's installing quite a few things, putting things back in, removing some other things. So let's see. We'll keep letting that run along here. We may also want to try LSPCI or something similar to be able to determine where it is actually on the hardware. So what we can do is actually come over here while this is running, and let's go ahead and duplicate this session in order to be able to do two things simultaneously. So we'll do root. I will type in password. All right, and then it's here. I'm going to make it full screen just so we're not confused, because otherwise that's a lot of text on the screen. We're going to do LSPCI, see if that's available. It's not. So we'll have to install that, which we can't do while the other installer is already running. Otherwise it'll do weird things. So it did finish. That's perfect. Let's do lbu commit -d. And let's do apk add lspci, just so that way we have PCI devices available. Excellent. On apk search lspci, because we can search by just the executable, and we're going to do apk add PCI utils. We probably borked the installation. Let's do APK fix. Let's make this more verbose. Oh wait, I need to do verbose on the right side. It is not being very verbose. All right. So it has no other network communication. Let's do ping, because it may not have DNS. Let's do ifconfig. DNS lookup, it may not have. It may not like NS lookup. I may have to do dig. So let's see. Okay, so it doesn't have that. I am just going to restart networking first and then do the IF up down. So it is still there, and we'll do and let's just do, we'll save the config as it is, and then we'll just reboot once more and see what we get to. I'll just turn this on again just in case it magically decides to start. That would be amazing. We do see activity, so it's doing things. Should start much faster than it did the last time around. So let's see if we got there. Still booting up. But it definitely looks like it messed up the Ethernet configuration somehow. So it is getting local access, but it doesn't have the name server to actually resolve to. So we can always correct that should it be needed. Hopefully then rectify the issue associated with it and continue troubleshooting. It's still loading. All right, so let's try NS lookup. Google.com again says connection cannot be reached. So what we're going to do is we're going to do vi/etc/resolve.conf. Right, and we're just going to enter an name server here. And we're just going to do 192.168.30.35.1, which is my local name server. Save that out. Try it again. Otherwise, there's another way we can enter it as well. So let's do echo. Oh. Oh, it does say it's full. Oh, that's interesting. Let's see where it's full. Right, so slash it says is 1.2 gigabytes. So firmware. Right, because we want our pi. So where is all that space going? Q limits. Let's pull this off the screen really quick so we can see this. Whoop. Not much in Python. Okay. So here we have firmware. We don't need NVIDIA. But I know that one's huge, and that's probably taking up all the space. Alright, let's nuke it manually. So let's just get a location of it. So under lib firmware, we can go to town from there. Yeah, /lib is 418, which is the entire thing. Alright, so /lib modules. Then we should be able to get rid of Intel. So let's do so we're gonna do rm-r, so Intel. It's really annoying. Do I need to do a capital R? I don't think I do, but we're gonna do it anyway. Oh, it's saying read only. Because it doesn't have any space. Alright, so there's one way that we can get rid of this, which is by deleting the actual source files from the cache and then rebooting without internet access, and then hopefully it won't be able to download it automatically. We can then just remove it and go from there. So let's do that. So we'll do mount -o remount rw /media mmcblk0p1. Alright, now we'll go into ls /media mmcblk0p1 cache, and we see everything here. So everything that says Linux firmware, we're gonna nuke it. So let's do this. I just want to make sure. Okay. So we're going to go with that, and because it does have the backup repository in the APK folder of there as well, so the baseline installation for making it actually run generally should be fine. So let's do that. Now we can mount this as read-only. I'm not going to update anything, and I'm just going to reboot. And let's see what it comes back as. So we've deleted everything at this point. That is Linux firmware or Linux LTS, etc. Anything that starts with the Linux preface, which should take us back to bare bones. That way we can go in, we should have the space to be able to delete it. It shouldn't be able to install it at all. So let's see what we got. So we see it. It's not really doing much right now, which is good, because to be honest, it should be a lot more bare bones, right? Okay, we'll do df-h. We see we're only using 22% right now, so we're going to do APKOVL Linux LTS and just get rid of that. Right? So there we are. So now we can do APK update. Right, it fetches everything. There's no memory errors, nothing like that. We'll do lbu commit -d. Now we're back at baseline. Okay. So minor digression. So let's keep going. So we have, let's do apk add PCI utils, which is what we looked up earlier. That should get us LSPCI. Can't find any working method. Perfect. I'm just going to do APK fix really quick, see how much it installs. That's perfect. And we may still be borked. So let's take a look at that really quick, because we did not install that. So tar This one talks about Mesa driver Gallium for 4 and 5. This is a very old article, by the way. Somebody kind of updated it. everything that's required in order to make it boot and run should actually be installed in the kernel in this particular image. So this one, Linux firmware Cypress. Linux firmware BRCM. So we may actually want to install those really quick. I don't think it liked that. Because none of that installed correctly. And let's do APK cache sync. Cool. So let's do mount. Let's keep messing around with our user config file. I'm just going to put DSI 0 here, which was what it said in the wiki. So if we go back over to here, it said the comma DSI 0. It says only for those. Trying to think. I have another resource I could check. What would it be? Because I have another one. This is the wrong one. So maybe, let's see. Yeah, okay. So this is what I have set up for that. So let's try this. I'm just going to try this verbatim. Because it doesn't really matter that it's a 7-inch LCD. I have another one that I used as well, which had a the similar type of screen just without the bezel, and it was perfectly fine. So let's just try this really quick. Just looking really quick to make sure. I didn't install that cable backwards after all of that. That would be really funny. I don't believe so. But leave everything on the table, you know. Literally or otherwise. Alright, so now that we've done that, let's go ahead and reboot, and let's see what we get. Because the other thing, I'm not seeing power or any kind of sign of life on this LCD screen. I would expect something to come up. That's kind of what's concerning me. So I do have the other cables here that we can potentially try, which are a little more traditional. I think this one's like a little bit different. Let's just check that out before we continue. I want to make sure that we're not doing something here that's making it not like it. I'm gonna need a tool. Right, and there's no on-off switch here. Let's make this full screen here. Because I'm going to pull this entirely out. There's no power connector or anything else like that on there, indicating that it would need the additional power for it. Although we could try an external power connection. Right, the only connectors I see in terms of contacts are on the side that we were facing, right? And I do see good connectivity in terms of the dimples that are left in here. On both sides. Right, and just pulling off the PoE card, or the PoE adapter. Right, it does say display. We're plugged into the right connection. Alright, just looking under here really quick. I didn't check all of the connections under here to make sure that they were secure. I assume they were secure from the factory. Which may... if you could see it under the board, there's some massive connectors there. So that is something. So I do think we're on the right track in terms of using how we're using it. I just think it's not running it. So let's see what we got. Right, this isn't getting overly warm or anything. So we've reseated everything. Still no signs of life. I do have another Raspberry Pi or two I could try. Just for fun. See if it's an interface issue. But right now we're running pretty much the ideal circumstance, which is known working code. And actually, I think I even have... a another one that we can even check out. Alright, and that's living room, so let's do... And this one's running a 7-inch DSi display as well. So we will see. Because that one was running pretty much the same thing as what we started with. because it literally is not supposed to require any kind of special configuration. It's just supposed to work. And my fear is that this may be a bad display. You saw me take it out of the box. That's literally the first time I took it out of the box. And that will be very disappointing. I do not see any kind of button or anything else like that on this. That would be for backlight control or anything else like that. So just for fun, let's just, instead of doing PoE, I'm just going to try plugging it into an external power supply. And let's just see what we get. Because maybe that's not helping. So we'll give it the best shot we can before we call it. I'm going to leave the PoE plugged in. Let's see if it blows up. Does not look like it did. Okay, it did come with the extra cable here. But this is not supposed to be required for power. So, I mean, it does say 5 volts and ground. Let's try it. So I have this header here with 5 volts and ground. And I will bring this over. If this works, I'm going to be annoyed slightly. Oh, if I can even fit it. This isn't... That's a little bit sketch. Okay, I'm gonna unplug the power here, and I'm gonna reboot this. Okay. I saw a light up. This requires power. The other ones did not require power. They just worked. Alright, let's reboot. Okay. Looking at the back here, right, we see a light blinking. We see everything has power indicators, everything else like that. We can go back to our original user CFG file. So no PCI devices. Let me just make sure this is not something I broke. Whoop. Okay, good. So LSPCI does not look like it works for this version. You need the ARH64 version, which is good. Let's get rid of this one since we're not going to run anything simultaneously. Let's go back over here. Go back to the WaveShare wiki. That's not much closer. So looking here, it does have the additional 5 volts and ground. This is not the exact model, but it is pretty darn close. That one's using a Raspberry Pi 5. Oh, no, it's because we changed the thing. I say that like it's a big breakthrough. We don't know if it is. Let's find out. So let's go back to our original version. Right, so here. Just gonna delete all of that really quick. Looks like pretty much the same content. It did say the additional things here. I'll show you while it's rebooting. But we could go back to trying to use this again as our primary, since it doesn't appear to be, still doesn't appear to be going. Okay, so at least we're getting somewhere. So and user config. So I'm just going to delete all of this. Let's just do a minimum right here. Please, just turn on. Go to your Pixel home. Let's see. Right, we do have the blinking light. I don't know if that's a good thing or a bad thing. There is a VCOM here. I don't know what the significance of that is. The SDA-SEL function should not be required. let's just try this really quick. I mean, it says we have to install some stuff, the brightness. And that's just for the UI, but we should be able to just touch it directly. So let's see what we got here. So we'll go back into this. Let's just make sure, because again, it's not doing anything. We don't have sudo on the system. So just checking this out really quick. So I do have a theory, and it's like we worked it when we tried to do the workarounds for clearly not having the appropriate power connected to it. So let's actually try and rectify that first. What I'm going to do, I have another SD card here. I'm just going to reload it, doing the same procedure that we did before. And let's see what we get, because it may just be... I just want to see a display. Because once we do that, then we can move everything over, and it should be fine. So we'll go into disk management. Does look like this is already formatted, maybe? I guess so. Yeah, so this is already formatted, so we don't have to reformat this. So let's go over here. We can open up downloads, Alpine Linux extract 2. Send it to our USB drive, which should already be FAT32. We'll just go with it. For Mac compatibility reasons, I doubt it's NTFS. Okay. Whatever that is there is like really annoying me. And I think it's the exposure. It's the corner is somehow falling off because of exposure reasons. So if that's been triggering you, I'm sorry. Alright, so we have this here. I'm going to go back over to here. I'm going to copy this into it. And just for fun, copy this in as well. All right, we'll eject this, and let's go ahead and shut down the Pi. We will have to disconnect this again in order to put in our SD card. Not a giant pain at all. I am going to use pliers. Try and get this out. Okay. So we will pop the new one that we just made in. Reconnect our DSI connection. Press it down. Now, it's not going to be able to run the software because we have to do those fixes again. But let's see what we got here. See, that's much better. I don't even see it trying to start up. Again, I'm just gonna plug in. Well, let's do this. So what I'm gonna do, I'm gonna unplug the PoE. I'm going to plug this directly into the header. And then we'll try again, because it didn't boot up. So let's try it. Because I'm not convinced that this is not just an issue with the actual board here. Where are we supposed to plug this in? So the second pair. Right, that looks reasonably close if I had it the other way. So now I can plug this in, and then I have this connection I can plug in, and there's no PoE hat in the mix. Right, I'm not seeing any difference in terms of signs of life here. Since it doesn't matter, I'm gonna futz with the VCOM adjustment. If this works and it's not calibrated from the factory, I'm gonna be kind of PO'd. No, I'm not seeing any further signs of life. It literally did not come with anything else. So it's not like we missed some documentation or something like that. I mean, we have the box, but the box literally says nothing. It is designed and built for the Raspberry Pi, right? Nothing hidden. All right, so let's try a different Pi really quick, just because this is where we're at. So, I mean, we finished everything else we were gonna do because we, got all the programs transitioned, everything else working. We're just trying to get the physical thing working so we can have, some kind of reward for all of our effort, since this is really the reason for the project. But it's not looking like it wants to partake. So just for fun, let's just try another Pi. because I have a Pi 4. It says Pi 4 and Pi 5 supported as well. And I have both of those that we could try one and see how it goes. So I'm going to use the longer cable for this. I do have some longer jumpers. So let's pull. That one's probably not going to work. I don't know if you can see this. Whoops. It's right underneath the heatsink, and I don't think there's a way to reasonably get to it. So we have a Pi 5. So we can try this. I'm just going to pull it entirely out of its case. And this one, oh, this one is mini. So this requires this mini cable. So now my thumbnail is not false advertising for me being lazy. It is actually including a Raspberry Pi 5 in this. Let's see. And for this one, we're going to put it in 1. Let me make this full screen so you can see what the heck I'm doing. So I'm gonna pull this up here. Okay. So that is doing stuff. We still need this. So we'll put this back. Right there. We'll run it into this. Same deal. Which I believe has to go like that. Is that right? Let's look. It shows it on the outside 2 pins. Oh, this has a direction. Okay, we had it plugged in last time. I was like, why is this different than last time around? Okay. So we'll put that in like that. I do have a USB power connection. This is gonna get sketchy really quick. So we'll just plug that in. We have the same blinking light. Oh, I don't have a... Well, let's see what we got. Well, there's still no output. There should be a bootloader running on this. Like, literally, I don't have a USB key in here at all. It should be showing the bootloader. Like, there's nothing... It should just be running stuff. So I think this LCD may be dead. Because we do have the power light blinking. I will take the SD card, which probably won't run in here, but it should tell us. We could also just try a baseline install and not have any of the packages or anything else like that we had. I think we'll do that as one final failsafe. I'm gonna install like AArch64 or something. Run it on the Pi 5. Because it could be that it actually requires the 64-bit OS for this, which was not documented anywhere, but that wouldn't be the first time that something like that happened. So I still have downloads open, so let's go over here. We will do AArch64, tar.gz, download that. Okay, we'll go over here. All right, we're just gonna delete all of this. Wait for it to update. Okay. It stopped doing things a hot second ago. Well, there it is. Okay. So, AArch64. Yes, I know I need to rebuy it. Okay, we're gonna pop it right over there. Watch it do things. Then we're gonna do nothing. Plug it in and see what happens. That's what we're going to start with. And then the last thing I want to try is just creating those two entries, since this is Raspberry Pi 5, which is its optimal use case. And then we're going to just say the display is dead. For better or worse. Okay, so we got that. Just gonna plug this in. This has literally no network connection at all. I'm gonna try not to rip stupid cable or short anything out. Just confirming there is the blinking light on the bottom of this and nothing at all. I think it's dead. After all of that, I think it's just, it was never meant to be for this screen. Everything is securely connected. It's doing things on the Pi. It is still blinking. All right. But I do not see any signs of life. All right, well, for better or worse, that's what we got. So here, I'll pull up a clock just so you can see it running. So this is what we got to. Ignore this. So we made this work. It It is doing what it's supposed to. This is through SSH, not through the actual display output, so you see the lines, but that's pretty much what we got. Nala's saying hello. You want to come up and say hello? Woo. So, if you made it this far into the video, if you made it this far into the stream, thank you for watching. I definitely appreciate it. Be sure to hit that like and subscribe button. That way you know next time you can be underwhelmed and disappointed by whatever project we're planning on doing next. So, until then, take care. Thanks for watching.